thank you everyone for coming. I'm Alex from CloudAcademy, and tonight I would like to share with you some, preview and fun facts and tips and use cases as well about Lambda Edge. So how many of you have played with Lambda Edge so far? No one? A couple of guys there? Okay, great. So before we get started, well, I'll tell you a little bit about me. I'm a computer science guy, computer scientist, software engineer, web developer, however you call it. I joined CloudAcademy a few years ago, and I started playing with serverless computing about a couple of years ago, as everyone else. And I'm organizing the same meetup in Italy. I'm Italian, so if you ever end up in Europe, I'll be happy to welcome you. So before we actually get started, I wanted to do two things. So David already asked you if you're using Lambda, and plenty of you are. So I wanted to ask you one more question. So how many of you are actually using CloudFront in production? Okay, 4, 5, 6 people. So I'll get to why this is interesting, because that's what Lambda Edge is really about. And then I wanted to share with you I wanted to ask you something. So I'm doing a little, I'm running a poll. Like, I have a side project that I wanted to share in the next days. And if you check my account on Twitter, I wanted to, share this poll with you. If you take 30 seconds and answer. So it is about Lambda optimization and power tuning stuff. So please take 30 seconds of your time, and next week I'll share the results. Okay, great. So what are we talking about today? First of all, so what is Lambda Edge? More or less how it works and what you can, what you can't do. And then we're talking about use cases tonight. So what are the most interesting use cases? It's in preview mode. So you're not free to do everything you want. You have to apply for the peer review. And it will be generally available in a couple of months, it should be. And then I will also share a personal experiment about, it's not real world yet because it's preview, but I will share the code and a little demo as well. So what is it? Many of you are using Lambda or Google Functions or any other function as a service provider. And so to understand what Lambda Edge is, we have to talk about Lambda a little bit first. So what's the difference? What's the main difference? So generally, simplest use case ever. So you have a Lambda function, an API endpoint in front of it, and you're using or calling it. And well, you have to choose a region, in AWS. So imagine you choose US East 1. So what happens when you really have to scale and you have to deploy your functions and APIs and maybe your database too into different regions? Well, you have to duplicate everything, right? Which is super easy with the serverless framework. But basically you have to replicate your infrastructure in a way. So what if I told you that you could deploy your Lambda functions to more than 70 edge locations with one click? So that's more or less what Lambda Edge allows you to do. So you write your Lambda functions, and instead of choosing where they are deployed and how people will access them, basically your Lambda is deployed to every CloudFront edge location, and we'll get to the main architecture. So CloudFront is a content delivery network. It's mainly, so far, used to distribute static content or to cache dynamic content. So you put in front of your origin either an S3 bucket, an EC2 instance, whatever content you have to distribute. And so far, it was the only way to use it. You just put a distribution in the middle, and your users will either hit the CloudFront cache or miss the cache and go all the way to your origin. So let's say your origin is an S3 bucket in London, in the London region, and then you can distribute this content to everyone in the around the world with these 70 and more point of presence, CloudFront's edge locations. So let's talk a little bit about what CloudFront is, so what are the features and what we can do, because basically Lambda Edge is, let's say it's more of a CloudFront feature than a Lambda feature. It's more related to the CloudFront world in a way. So what can you do with CloudFront? Well, as I mentioned, you can do static content delivery or dynamic content caching. These are the two most interesting use cases, I think. And there are many edge locations. You can have custom domains. And of course, you can invalidate this cache, and you have a beautiful dashboard to see all the most popular objects and what's the error rate, what's the hit or miss rate. You can set up your custom origins on EC2, S3, and blah, blah, blah. Of course, you can base your caching logics based on headers and cookies and query strings. You can do a lot of interesting stuff. I mean, whatever you would expect from a CDN, more or less. As I said, there is a beautiful kind of dashboard that shows you, the most popular objects. At CloudAcademy, we use it for video delivery, so we can allow our students to watch videos all over the world. And so you have this nice dashboard. You have statistics. You have daily error and hit and miss rates, and you can have this for every distribution. So where is Lambda Edge fitting into this infrastructure? Basically, you have the same overall infrastructure, so a user, a distribution, and an origin. But you can put Lambda function in the middle, in between. And there are 4 different ways to do this. So the first one is coming from the user to the CloudFront distribution. So you can execute the Lambda function right there before hitting CloudFront. Or you can execute the function once the value comes back, once the resource come back from CloudFront, either a hit or a miss. And then you can manipulate that response before returning the response back to the user. And then there are 2 more possible ways to use Lambda Edge after the CloudFront distribution, so between the distribution and the origin. So you can, in a very similar way, execute the Lambda function as soon as a miss request is going from CloudFront towards the origin, so before going all the way to the origin, because Lambda at Edge functions are always executed at the edge. Or you can execute Lambda function after the origin returns the resource back before caching it into the CloudFront distribution. So these are the 4 possible triggers that you have. As you would think of Lambda triggers, you have S3, you have Kinesis, you have DynamoDB streams. Here you have CloudFront. And within CloudFront, you have these 4 possible triggers. So viewer side, it's the first 2 I mentioned, viewer request and viewer response. And the origin side, you have origin request and origin response, very similar. During the preview phase, you can only have one of those active per distribution, which is kind of limiting. There are many use cases where you can combine and implement different kind of logics within the same distribution, like before caching, after caching, before hitting the origin, whatever. So the second section of my presentation is about what are the real use cases, what could we do. So I made up 3 categories. You will not find these on Amazon. I just kind of found a way to organize the use cases because it's useful, I think, to understand why and what and when not. Also, it's really useful to know. So the first category is about just request and response manipulation. Whenever you need, what you need is to take the request that's coming from the user or from the distribution to the origin, or the response going back, and you need to sort of manipulate it, change something, adapt it to the client, or basically do anything about changing the resource. Second category is about just generating content. So imagine you want to have these 70 edge locations be your 70 data centers. Okay, so you want to push your content as close as possible to the user and then make it dynamic with dynamic code, dynamic Lambda functions at the edge. So there are a few use cases about this. And the third category would be latency optimization. So you want to optimize the experience for the user and at the same time, eventually, reduce the load at the origin. So it's about really only optimization. It's not a special feature that you wouldn't implement otherwise. It's just a way to improve the experience and the origin load. And there are a couple of use cases here too. So let's see each category. request response manipulation. So since you have access only to data that's available at the edge in Lambda Edge functions, so you can deal with HTTP headers, with cookies, with data that you have packaged within your code, so like your deployment package files. And you can't really do everything you want. You cannot query S3 or Dynamo or RDS or whatever custom resource for now. So what are use cases? Well, imagine you can play with cookies. So some people thought, well, I can do A/B testing. I have a file, a video, an image, something to A/B test. So I store the variation, A or B, in the cookie. And then whenever the same user comes back with that cookie, I know which is the variation, and I give the same resource back. So you can do like cookie-based A/B testing, for example. Or you could do URL rewriting. So imagine you have a, I don't know, like a dynamic origin that it's like a service, and it's taking, I don't know, a lot of query string parameters, and you don't want to expose those parameters to the final API user. So maybe you can transform like explicit parameters into query string parameters, and you can do any sort of rewriting, because at the end of the day, the URL is an header. So you can play with any kind of header. So I was in London a couple of weeks ago, and a clever guy mentioned that you could do encryption at the edge. So I think what he mentioned is that imagine that you want to encrypt everything that goes out of the AWS data centers, edge locations included. So you might use two of the triggers I mentioned to decrypt everything that's coming from the user and then encrypt it back when the response comes from CloudFront or the origin. So this could be interesting. I would expect encryption to be built into CloudFront, but if you have any sort of custom use case about encryption, about your content that you want to distribute, that's an interesting use case. Another one is to adapt the resources that you want to distribute to each specific client. So imagine, how many of you know the WebP image format here? A few? Okay, so it's a special format that not every browser supports. So for example, some image delivery services are using a very similar approach to say, so a browser comes and it requires an image, request for an image, and if that specific browser supports WebP, I will compress the image or redirect you to the WebP resource. If not, I'll give you the normal image. So this is kind of a optimization or say usability thing that you can do to adapt responses, not requests, but responses. Or you can do, you can manipulate the response to add dynamic time zone related information, like the time zone. If you are in a specific edge location, say London, say Sydney, say wherever, well, you can add information to the response about where your Lambda function code is actually executed. So it could be the time zone, it could be, I don't know. It's really about you. There are many use cases. Second category, dynamic content. I think this is the most interesting one, and I have a little spoiler. It will be much better with general availability. This is about, and there is an asterisk. The asterisk is never hit the origin. So in my opinion, this category is cool because you can actually do what I called originless computing. I mean, you can do everything, really everything at the edge and never go all the way back to the origin. Because imagine that I package with my code some kind of JSON or XML file whatsoever, and that's kind of my local database. Imagine your data doesn't change for a week or for a month or for a year. So you can basically push all your data to every edge location and then serve dynamic queries or filtering or do any kind of stuff with that data that you have there at the edge. Another cool use case is about, for example, optimizing JS code. Do you know polyfill.io? Anyone? one. So it's a nice service. It's not based on Lambda Edge. I asked them, but it's you could do this with Lambda Edge. So they JavaScript polyfills are kind of pieces of code that all browsers need to kind of behave like modern ones. So what people used to do is like, is this Internet Explorer? Okay, so add these polyfills. What polyfill.io can do for you is, well, you in your code, you always request the same JavaScript file that they deliver for you with a distributed CDN. And based on your specific browser that's doing the request, they will give you the subset of polyfills that you need. So the response will be much smaller, kind of like 0 if you're using Chrome or Edge. So this is an interesting way. And the way you could do it, as I mentioned, is you put everything you need, all the possible polyfills in your deployment package, and then when the Chrome or Explorer or Firefox request is coming, you check the user agent, and then you put together only the polyfills that are needed and push them back to the user. Other cases, well, imagine you want to build custom error pages or sign up forms that eventually require dynamic data that you have at the origin, at the edge, or that the user is giving to you with headers or cookies or whatsoever. You can build this kind of dynamic content that could be HTML, could be JSON, could be any kind of resource. I think the most interesting scenario that I actually implemented, that's my experiment at the end of the presentation, is about dynamic HTML. So I wanted to create a real HTML server-side rendering example where the HTML is rendered in a Lambda function at the edge. So there are like 70 edge locations that can return dynamic HTML with dynamic data without querying any database, of course. But the cool spoiler here is that at some point, I don't know when, nobody knows, you'll be able to actually query dynamic data at the origin. Not for now, during preview. But if you think about that, you don't want to always do it, but since there is the CloudFront cache in the middle, it allows you to fetch only data you need, generate the dynamic content, and then give it to CloudFront that will cache it for a while. So it's an interesting scenario. And all the manipulation, all the filtering, all the interesting computational intensive stuff will be done at the edge. So you just fetch the data. That's kind of cool. Third category, whenever you want to just optimize the user experience or to imagine like you want to reduce the load. When do you want to reduce the load? Well, imagine that you have an origin, like a dynamic origin, that requires authentication always. Why do you have to go all the way back to the origin? That's maybe in Australia or in Seattle or in London, if there is no authentication header. So why don't you just tell the user, I'm sorry, you have to provide authentication. It's a 401 error. Well, you can do it as soon as possible at the edge. And this means all those unauthenticated requests will not go all the way to the origin. So you have better load, smaller load, and much faster responses in those cases. And then any other kind of custom logic about validation or data transformation, well, you can do it at the edge. Imagine that you cannot change the origin. And so here the assumption is that the origin is a dynamic service and you're using CloudFront only for caching. So if you cannot change the origin, it's very cool that you can put a Lambda function as close as possible to the user and either manipulate the data before it goes back or just validate it. So same as for the authentication header that was missing, here we can validate the data at the edge and return an error as soon as possible without even hitting the origin. Well, another one would be, imagine you want to log something super spatial that you only have at the edge and you do not have back at the origin, or maybe the origin is just static files, so you really want to have some custom logging, and you can do it. The limitation is that you cannot do HTTP calls, but you can write CloudWatch logs. So you just write logs and maybe you will parse them later on. Okay, I couldn't think of any other, but if you have super cool ideas, I'll be here later. So what can you do now during preview, and what's going to happen with general availability, and what about pricing? Let's see. So these limitations are here only during preview phase. And that's, I mean, I know that for sure. So the biggest one here, I think, is, first of all, only Node.js. I mean, I'm a Python developer, sorry. And then the 1 megabyte code limitation. So with Lambda, you have like 20 and 256 megabytes, I can't remember. So here we have 1. So how many Node.js libraries you know that are less than 1 megabyte? I kind of struggle to find a server-side rendering engine, template engine with less than 1 megabyte of code, but you can find it. So that's going to disappear. You'll have a bit more of storage available at the edge. And also you have to, your invocation must finish within 50 milliseconds, which sounds like very little, but when you cannot query database or do HTTP calls, it's kind of a lot of time for pure computation. And you cannot currently choose any power, like any memory or CPU power. And as I mentioned already, you can only have 1 trigger. And let's say that the programming model is slightly different, meaning that for now, at least, there are some little differences that, when you test your code in the Lambda console, with respect to when that same code is executed at the edge, you will have slightly different results because of stupid little conventions, but they will disappear. On the other hand, what is permanent? What's not going to change? Well, you're familiar with cold starts. Some people asked about them. They are there as well. They're much faster, and I couldn't really find a way to measure them because the propagation time from the moment you save, you update your Lambda at the edge, to the moment it's actually propagated to the 70 plus edge location could be 5 to 10 minutes. So it's kind of hard to understand what's the cold start. You have no trigger, no idea what's going on for now. Hopefully that will change too. But cold starts will probably stay. Also, the only Node.js, because at the edge you want non-blocking I/O. So Python, Java, I'm not completely sure. As far as I know, Node is here to stay at the edge. Again, the propagation is a bit slow. Some people ask me about API gateway distributions. So that will be very interesting. But those distributions are currently hidden. When you create an API gateway, you can't see the CloudFront distribution because that dependency might actually disappear at some point. So they don't want to expose that to you. And also the same holds for Lambda at edge. Of course, VPC doesn't make sense because you are at the edge. That letter queue, that's kind of complicated. I'm not sure if I would use it at the edge, because if the whole point of DLQ is, okay, something went wrong. I want to have a way to restore that event, maybe reprocess it later on, maybe retry it, or just analyze it. But at the edge, you're serving content, and as soon as you fail to respond to the user, you can't fix it. You fail to respond. What about real-time logging? That's kind of impossible because you have 70 edge location. Every time you log something, all those logs will go all the way back to the region where you defined the Lambda function. And it's impossible to have real-time logging. It will take a while to propagate back to where you defined the function. Another little limitation, it's a limitation, this is more of a annoying thing to do. You have to take care of every HTTP convention. So when, for example, with the viewer request trigger, when a request comes, well, if it is an option request in the HTTP protocol, well, you cannot return a body. You have only to return headers. So if you don't take care of that, you will have an error. Or if you return, I don't know, like a 204 status, that's a no content status. And if you return a body, that's an error too. I mean, you have to take care of all the HTTP protocol rules. And that's not done automatically. I would expect that, but they told me it's here to stay too. So what about general availability? It's coming soon, few months hopefully. And well, this is very exciting, I think, because when I started playing with Lambda Edge, I thought, okay, I will never be able to query a database. I will never be able to, store a file or read a file from S3 or anything really dynamic, but it's coming. So HTTP calls, you will have an SDK, you will be able to query real data, which will allow you to actually generate dynamic content. And if you remember the architecture, well, you will not be able to do dynamic stuff close to the user. You will have to do it behind the CloudFront cache, because of course you don't want to wait, I don't know, 2 seconds or 500 milliseconds, while the user is waiting. You want to fetch data, cache it, and then return to CloudFront. Well, of course, you will have multiple triggers per distribution. That's interesting. You will have a way to configure memory and timeouts, and you'll have much more storage. Hopefully, I hope at least 50 megabytes. With my examples, I had a couple libraries. I really had to hack those libraries to make them 1 megabyte. So if it was 20 or 50, it would be much better. And also the location awareness of your Lambda function, now it's like 0. I mean, you cannot say, I'm the Lambda Edge in London. You don't have that data available at runtime. So that will improve too with the general availability. Okay, what about pricing? It's a bit more expensive than Lambda, quite a bit. So the model is similar to Lambda though. So you have number of requests and how long they took to execute. There's no free tier. There's not going to be any free tier, unfortunately. And the granularity of the function is not 100 milliseconds, it's 50 milliseconds. So imagine that you have, I don't know, in my example here, like 6 million calls, you'll spend $5.60. It's not crazy. Okay, let's keep going. I have a little experiment that I want to share with you. It's really simple. You can check the code later. I will show you the example only. Okay, so I have a CloudFront distribution. There is only one file, and that's an index.html, and that's the file that you see here. That's a static file available on S3, and it's served through CloudFront. But then I have another file that does not exist at the origin. But if I go there, if I load this dynamic file, took a while because it was probably a cold start. What happened here? So if I reload the page, you see that the date is changing. So I'm just printing this dynamic content that's just a date. And I'm not hitting the CloudFront cache. I'm not hitting the origin. This is dynamically generated at the edge. Indeed, if I try to, this is tiny. If I try to curl it to get it, okay. You see this Xcache header is not hit from CloudFront, it's Lambda from CloudFront. So you see it's actually generated from Lambda Edge. And well, if you check the code, it's really the stupidest thing in the world. It's a test.html file with a title and a date. I couldn't use any super powerful rendering engine, so I can't even remember, it was very simple. But you'll find that on the gist, it's public. And well, there's probably 90 lines of code, and I'm doing HTML minification, I'm doing gzip compression, and I'm doing server-side rendering. These are the two template variables I was rendering. Okay, that's it. Thank you very much.